Hello, and welcome back to a video series on MAT 1033 Intermediate Algebra. My name's Sean Perry. This is video 15 in the series, Systems of Equations, Part 1. In this video, we're going to look at a graphic interpretation of systems of equations. But for right now, before we talk about systems, let's just remember what an equation is. Recall that a single equation, y equals, say, mx plus b, is a way of describing all of the pairs of numbers x comma y such that the equation y equals mx plus b is actually true. That is to say, if you take x and you times it by m and you add b to it, you will actually get whatever y is as a coordinate pair. And that if you trace out all of the points x comma y that satisfy some equation that looks like y equals mx plus b, the collection of points that you get actually just looks like a line. Now, a system of equations just means a collection of several equations. In particular, we're going to be looking at systems of linear equations, so really we're just looking at collections of lines. Now, a solution to a system of equations, if there is one, is a point, or maybe several points, such that all of the equations are true at that point. So all of the equations will be satisfied by that particular point. Let's look at something we've already done as an example. When would the line y equals 0 and the line y equals 2x plus 4 be simultaneously true? Well, I would need y to be 0, and we know that that is the entire x-axis, and we would need y equals 2x plus 4 to be true, which these happen at this orange line and this red line respectively. So where are they both true? That's the question. And the answer is, well, at their x-intercept. Right, where it intersects the x-axis. That is the intersection, what they have in common of the line y equals 0 and y equals 2x plus 4. So when we look for solutions, we're actually looking for the intersection of lines. Let's look at that a little bit more generally, right? What if I have just two lines, red line, blue line? Don't worry about the m1, b1, m2, b2 here. Don't worry about that. They're just any numbers you wanted to stick in here. Let's just say we have a red line and a blue line. Where are both those equations true? The red line is true at every point on this red line. The blue equation is true at every point on this blue line. So where are they both true? Well, yeah, they're both true right here at their intersection, which I've just called AB for no particular reason, right? At this point where the line red and line blue crisscross each other, they are both true. And that means this point, whatever it is, AB, would be a solution to this system of equations. So try to take advantage of the fact that your brain is naturally able to pick out the intersection of lines. Actually, all of ours are. Our brains evolved to pick out patterns from our environment. And we are all, each and every one of us human beings is hardwired with the ability to see this as being a very special point. And so let your brain guide you towards that. This special point is in fact the special answer that we're looking for. When we look for the solution of a system of equations, it is precisely the intersection of the two lines that represent each equation. So here's a particular example for you to chew on. Let's say I have the line y equals minus x plus 4, slope of negative 1, y-intercept of 4, and y equals 2x plus 1, slope of 2, y-intercept of 1. Those are graphed to the side here. What's the solution to this system? So the solution to the system is the intersection of the two lines, and these lines seem to intersect at the point 1, 3. And so 1, 3 is our solution, but does that work? Does that really satisfy these equations? Well, let's plug it in and see. If I plug in the x value of 1, I get minus 1 plus 4, that's 3. So it satisfies the red equation. And does it satisfy the blue equation? Well, if I plug in 1 times 2 plus 1, that is also 3. So it satisfies both of them. It satisfies both the equations, and that means that it's a solution to the system of equations. Now, we just found out that a single point can be a solution, right? The last example had a single point that's a system, so did the first one. But is that the only kind of shape that's possible? How many kinds of solutions can I have? What I want you to do right now is I want you to stop and ponder this. How many different shapes can we get when we intersect two lines, right? Is there only points we can get, or are there other options? Are there only special options? Stop right now and give it some meditation, right? And think about it. Now, to get you guys to think about this, I highly suggest taking advantage of all the technological capacity that you can, right? I don't suggest using technology to just, streamline your homework. that's really doing a disservice to yourself, because you need that exercise to learn this material. However, when you're starting to think about questions and when you're trying to explore, you should use technology and all the power it has to offer. Here I'm at Desmos.com. You can click on its graphing calculator and you get a free graphing calculator. It's really nice. You can plot just by typing, lines, all sorts of equations. We'll take a look at this a lot over the course of the year. But one of the main things I want you guys to learn how to do is to type in some letters here. Let's type in y equals mx plus b. And notice it prompts you, do you want to add a slider? Let's add all of them. And let's see what this just did for us. So they've picked a value for m of 1. They've picked a value for b of 1. And it's given us a slope of 1 and a y-intercept of 1. And now we can kind of explore. What if I change the slope? What does that do to the line? How does it look different? How does it look the same? Notice the y-intercept is frozen because I'm not messing with that. But I can make the line really steep and negative. I can make it really shallow and negative. I can make it flat. And then if for slope of 0, I get a horizontal line. I can make it shallow and positive. I could make it steep, right? And so this lets you actually play. This lets you actually play with slope and see what it is for yourself with not just one picture, but a whole video's worth of pictures, really. And same thing with the y-intercept. What does that do? If it freezes the slope, it doesn't change the inclination of the line. It just moves it up and down without changing the slope. Okay, so now let's kind of use this to explore what we could do to find an answer to the pondering question here. What about 2 lines? Okay, so let's put a second line. Y equals, let's put capital MX plus B. Desmos will treat capitals as different from lowercases. And here I've added a second line, okay? So if I start playing around with slope, right, it doesn't change the y-intercept, so that keeps the intersections just a point. If I change this, okay, so it's looking like, if I only have these 2 parameters to play with, it really looks like so far we've only seen a single point of intersection. But wait, there's something that happens at a moment, right? It's sort of a special case. Ooh, hang on a second, right? Well, what if they're the same line? You might think that's kind of boring, but what if it just has the same slope, but they're different lines by giving it a different y-intercept? Oh, okay, well, zooming out, those never actually hit each other. There is no intersection, which means there is no solution to the system. They're empty. It's an empty intersection. It doesn't really have a solution to the system of equations. There is no intersection. So if the slopes are the same, then we have a bit of an issue. There is no intersection. Now, if the slopes are the same and the y-intercepts are the same, okay, actually, that is the same line, in fact, right? They are not different from one another. They are just the same line. So actually, their intersection is the whole line. It's all the points. Any point that satisfies one line will satisfy the other line if they're the same line, of course. So that's it. That's the only 3 options, right? We have slopes are different. If the slopes are different, even if they're just slightly different, it doesn't matter. Eventually, those 2 lines are going to hit each other if the slopes are different. And if 2 lines hit each other, they must hit each other at one single point, okay? So that's if they are slopes different, they'll have one point that's their intersection. But if the slopes are the same, then there's 2 options. Either they aren't going to ever hit each other if the slopes are the same and the y-intercepts are different, or they are actually the same line, in which case they always hit each other, and any point that satisfies one line satisfies the other. We get a whole line's worth of answers. So let's encode that in some critical notes. Copy these down as proof you watched the video. There are 3 situations for the intersection of 2 lines. One is if we have different slopes, in which case there will be one point of intersection. If they have the same slope but different y-intercepts and they're not the same line, they never intersect and there's no solutions. Or if they are the same line, they have the same y-intercept and the same slope, well, then they always intersect, and any point that satisfies the blue line will satisfy the red line. There's actually an infinite number of solutions, just like there's an infinite number of points on the line. Okay, so now I have some praxis exercises I want you to do for today. I want you to match the system with its graph, and I want you to use the graph to solve that system. So let's get that all in frame, and pause the video at this time, and see if you can connect the dots. Okay, let's see how you did. So the first one has two different slopes. So we know it's going to intersect at one point. That limits us to A or C. Here we have two different y-intercepts, and so that's going to make C the correct option. We can also check slopes. This one has slope of 3, this has slope of 2, and we can see where they intersect. It's at the point 2,5. So this is the solution to this system of equations. Likewise, these have two different slopes for problem 2. If they have two different slopes, then we're going to intersect at one point, and that's this guy here. Notice that they have the same y-intercept, and that is in fact the point they have in common. So the solution to the system is 0, 1. This one down here has the same slope, but different y-intercepts, and that means that this is our match, and it has no solutions. There's only one left, so we might as well connect the dots here. But let's see if we could have figured that one out a different way than elimination. If I solve this for y, minus the 2x over, and multiply both sides by a negative, I get the original equation, y equals 2x minus 2. So the second equation actually isn't different from the first equation, it's just reorganized. And as such, they're actually the same line, and so they have an infinite number of solutions. Okay, that's all for this video. In the next video, we're going to talk a little bit more about the algebraic ways that we can go about solving systems of linear equations. Thank you for your patience. Have a great day and good luck with your studies. I'll see you in the next video.